Hi, welcome to another lecture on business mathematics. Today we are going to do several exercises related to functions and function notation. So first set of exercises ask you to write a formula that duplicates the set of instructions that are given. So what's the instruction here? A number x is given and we want to apply the following three steps in the order indicated. So we start with the x. First we multiply the number by 2. So first step is that the input is doubled. Next step is that we are adding 3, meaning we are adding 3 to whatever we produced in the previous stage. So 2x was done, and now we're adding 3. So right now we understand that this was done first, and then we add 3 to it. In mathematics, when we write 2x plus 3, it automatically means that doubling happens first, and then addition happens later. At the final stage, we are dividing our result of the previous stage by 4. So here it means that whatever we got the previous stage, we are going to take that and the whole thing is divided by 4. As a matter of notation, last time we said this is indicated by the following notation. Some name is given to this whole process. Whatever we are given, the process we go through, we give it some name. Most common name is f, standing for function, but it could be any letter or a combination. So f, and then we indicate what is it we start with. That's our input. The input goes inside a parenthesis. So far this was the name of the function. Not a very meaningful name, but that's a standard in mathematics. When you go to application, you can give meaningful names, make it longer and so on, but it's common in math that they keep it as short as possible. This one typically is referred to as the input, but the official name for it is independent variable. Independent variable. Either way. And we said this is equal to whatever is produced at the end of all this process. So 2x plus 3 is 2x plus 3 divided by 4 is the output. So indicating that we doubled first, then added a 3 and divided the whole thing by 4. Now it so happens that you can rewrite the same thing in another style. For example, you can write it as 2x divided by 4 plus 3 divided by 4. That function performs the same, produces the same result as this one, but the steps here are different. You can even continue to change this thing, like write this thing as x over 2 plus 3 over 4. That would be another equivalent to this function. The processes you go through these things are different than what we went through over there, but the final result is the same. So here, all that was needed is to indicate that this is our function, and as standard, we box our final answer to indicate what happened, but you always want to indicate your reasoning. First of all, you want to write the statement of the problem itself. You want to write this whole thing down. Then indicate what reasoning you went through to arrive at the final answer, and then you write the final answer, and not just this one alone. Okay, let's go ahead and take another example. So here's another example, number 8 in that list. F is a function that takes a real number x and performs the following three steps in order given. Subtract the 13, take the square root, make the quantity denominator of a fraction with numerator 4. So these are the things we are going to go through. So we start with Our input is called x. Again, that's tradition in mathematics. Can be anything. Subtract 13. So next step is to take that and subtract 13 from it. Next step is to take square root of whatever we had the last stage. Next step is to take a fraction, make that to be denominator of a fraction where the numerator is 4. Here are our steps. Again, our function is just called f. Our input is called x. Our output, so this is, so we said when we call this one is the input and this one is the output, and this one is just the name of the function. So name of this process we went through here, this all of this thing that we went through, we are giving that process a name. We call that any letter you wish. F, for example. F indicates that. The last time we emphasized not to confuse this notation from something from middle school. In middle school, if you have a letter, and then a parentheses and some number in it, let me erase this thing, peculiar thing showed up. So in elementary school, if you have a symbol followed by parentheses followed by another symbol, by another parentheses, this stood for multiplication. So at that time this meant A times B. Perfectly okay, and everything fine. Now we are giving an entirely new meaning to the letters. Why are we doing that? Well, because our typewriters has just a few keys. This notation was created around maybe 17th century or something, mostly for mathematicians, but then everybody else started using it, and you have to be aware of the conflict of the notation. So back then, A followed by parentheses meant multiplication. Here, something looking exactly like that, F followed by parentheses followed by some other letter, but now F stands for name of a certain process. That could be as long as you wish. It's not a multiplication. It is indication of what you want to do, and that what you want to do could be quite a lengthy operation. Nothing to do with multiplication. So we said something to be careful about when we are doing mathematics. From now, pretty much everything we do has to do with functions, and you don't want to confuse the two notation. It should always look at the context and see what does that letter mean. So it says f is a function. Okay, that's our clue that we are not dealing with multiplication. F is not a number. It's just a name of certain activity. Okay, let's go ahead and do another example. Okay, in the next set of problems, it says in exercises 11 through 18, use the given function f to find and simplify the following. So there are 9 things to do to each of those 8 functions that are coming up. Here, let's start with the first one, the easier one. F of x is given to us as, in problem 11, is just 2x plus 1. What do we want to do? We want to take all these 9 activities and do it and perhaps simplify. So what's the first one? The first one is f of 3. So again, you emphasize it's not multiply anything by 3, rather replace your x by 3. So 2 times 3 plus 1, that was easy, it's just 7. How about f of minus 1? F of minus 1, well, f of any input is double of that input, so twice minus 1 plus 1. Why did I put the parentheses here? Because if my input is some complicated thing, negative thing or something, I put it in parentheses in order not to make a mistake in following the procedure. So what's the procedure? Double the input, so minus 2 plus 1, and this boils down to just minus 1. Next problem is what's f of 3 halves. So it must be 4. 2 of, again, I put my parentheses here to avoid confusion and mistake. 2 times 3 half is just 3 plus 1, and that is 4. Next one is f of 4x. Now the problem is getting gradually more complicated. What does it mean? Here I suggest the following. F of, instead of letter x, perhaps use, suppose you belong to some advanced civilization and they have an alphabet, and their alphabet has a square in it. So whatever that square wants to be pronounced as, perhaps from Star Trek, Mr. Spock will come and pronounce it in some funny way, but f of that square is twice that square plus 1. I'm trying to wean you off the letter x. Sometimes you practice these things so much, you kind of get attached to the letter x, and then you make certain kind of a mistake. So what does that mean? If you think about this box, well, a box always has some stuff in it, and that stuff can be just anything. In this case, that box contains 4x. So let me put this in the box. Whatever here is, put it in a box, so we don't get carried away, distracted by the content. Let me just write it like that. So now this is just ordinary multiplication, twice that box. Like you have a box of gifts that contains 4 video games in it. Now you're getting 2 of them, so it's going to be 8 of that. 8x plus 1. That's it. This is called substitution. What we are doing here is substitution. Substitution, instead of the x that we had here, we are putting 4x. Of course, as you get used to this, they are not going to put the boxes for you. They just write 4x. They say, in your mind, you have to replace x by 4x. That becomes a bit confusing because, you know, you say, well, you have this operation, you have this, you have a 4 and x, and what am I supposed to do with it? Well, the process is that you are doubling your input. Your input is 4x, and then you add 1 to it, and out comes 8x plus 1. So that's officially how it gets to be written. However, I wanted to emphasize the notion of using a box as an input, so that whenever you do the substitution, you kind of think about you're replacing the content of the box with, you know, wrapping some new stuff in your old box. So that is 11. Let's see. Next problem is 4f of x. So 4, let me maybe mark these things. Let's see if we can mark them so that we can remember which is which. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this was problem 1, and then we did 2, and then we did 3, and then we did 4, and now we are doing 5. So in 5, sorry, it says 4f of x. Of course, they're kind of warning us of putting a banana peel in front of it. There's a 4 inside, this is a 4 outside. It makes all the difference. Where is that 4 showing up? So what is, how are we deciphering this? What's happening? Here, 4x, f of x has to be calculated, which we know how it's calculated, and then has to be quadrupled. Is 4 times whatever f of x was. When something gets complicated, we put a parenthesis around it so we don't make a mistake. F of x is 2x plus 1. This is that. That is multiplied by 4. So we multiply by 4. 8x plus 4. That's the simplified answer to this thing. So let's see. Problem 6. we are doing 6, which is f of minus x. Okay, f of minus x. This exercise is very nice and good. F of minus x, what does that mean? Again, I suggest this box notation. F of box is twice the box plus 1. No, fill in the box with whatever you want. In this case, we have minus x, so 2. So put this thing in a box. Remember, it's twice the box plus 1. No, the box has minus x in it. So minus 2x plus 1 is what comes out. And then problem 7. F of x minus 4. So problem 7, f of x minus 4. Again, the challenge here is what happens first, and to get around the confusion, put the input in a box. Remember, this is twice the box plus 1. Now fill in the box with whatever was there. Now, of course, officially they use a parentheses instead of a box. Now you carry out 2x minus 8 plus 1, so that is 2x minus 7. What else we have here? Say 8. 8. F of x minus 4. Again, this book is teaching you very nicely. Notice the similarity of how things are written and how widely different there are. F of x, so f of x, the input or the box of f has just x in it. That 4 comes later. So f of x calculates as before. That was 2x plus 1. That is just the f of x that we had here. And then we are subtracting a 4 from this after it's all done. So it becomes 2x, 1 minus 4 is minus 3. Sorry. So notice that these are different things. F of x minus 4 and f of x minus 4, these are different. Finally, we have our 9, which is what? F of x squared. F of x squared. So again, put this thing in a box. Remind yourself that the function takes the box, doesn't bother with the input yet, doubles it and then add 1. Now the input was x squared, and so I'll have 2x squared plus 1. So that was what we learned. Basically here is the concept of substitution. When the input of a function is replaced by some extended item. Instead of x, we had like x minus 4 minus x, x squared, and so on. Yeah, how does that change the output? Okay, now let's go ahead and do another example. In the next set of exercises, we are given a function f. We are supposed to find f of 0 and solve f of x equal to 0. So let's take one of these and carry it out. Let's take problem 27, the first of these things. Let's see what does 27. So what do we have? We have f of x is equal to 2x minus 1. First thing, it asks what is f of 0. F of 0, well, twice the input minus 1, and that is simplifies just to minus 1. Next, it asks you So this is part A. Next, ask you solve f of x equal to 0. That is, we are now asking for what input value x does the output become 0. So who was f of x? F of x is 2x minus 1. The question is, when does that's f of x1, when does that become 0? So we have an equation to solve. So take 1 to the other side and divide, and I get 1/2. Now, what is the significance of this problem? Well, we practiced 0 as the input, or 0 as the output, and we worked it out, but it has a much bigger significance. When you have a function, when you graph the function, it's some picture. In this case, a straight line, but it could be the picture of your function, could be anything. The sky's the limit as to how complicated it can be, but let me just draw something. So if you have a f of x, some generic f of x, it's likely that it's going to hit your axis. So here's a x-axis, is your y-axis, and you're graphing your function y is equal to f of x. More than likely your picture, your graph, hits the axes themselves. Where are these? Well, here, look, it's here, it's here. Well, if your axes are meaningful things for you, like these are days and the prices and so on, then any kind of a collision in your picture is some significant event that you are tracking, and you want to know how to find them. So on the y-axis, when you intersect your picture, this is called the y-intercept. Okay, the definition of that point is y-intercept. How do you find it? Well, what is this point? This is the point where x is 0. Every point on this y-axis, x is 0. So how do you figure out y-intercept? You let x to be 0, just what we did here. When you let x equal to 0, what we get is, the meaning of it is, this is the y-intercept we got. Well, how about this one? This one is the intersection on the x-axis. The property of x-axis is every point on it has a y equal to 0. So first of all, this is called the x-intercept. That means intersection with the x-axis. It is indicated by the fact that the y is equal to 0. Y meaning f of x is equal to 0. So if you set f of x equal to 0, and what you solve, what you get here is the x-intercept. So if I have the x-intercept and y-intercept, and I know my picture is a straight line, and these are two different points, then I have my job done. So if I draw x-axis and y-axis, and I say my y-intercept was -1, suppose this is -1, so this will be 1 on the x-axis, whereas 1/2, well, 1/2 is going to be at half point here is 1/2. So what I have here now, I have the x-intercept, and I have the y-intercept, and if I know this is a line, so I connect them, and that's the graph of y is equal to 2x minus 1, or if you wish, f of x is equal to 2x minus 1. Okay, so that is a problem from this category, and now we are going to move on to another example. Okay, next problem says, suppose f of x is equal to, now we have some rather complicated looking stuff on the right hand side, and then it asks us compute the following function values. So what does this mean? This is an example of a so-called piecewise defined function. Piecewise defined function. So what does that mean? It means a function that is defined in pieces. So here we obviously can tell that we have piece number 1, piece number 2, piece number 3. A function can have as many pieces as you want. First of all, what's the motivation behind this such a complicated looking thing? This in fact comes from business. In a business environment, it's very common that you want to do pricing or evaluation of something, and then you play some kind of a scenario. You say, oh, in this condition, that's how much I'm going to charge you. In the other condition, I'm going to charge you differently, and so on. If you go to post office and you want to ship something, well, it all depends. What's the weight of this object? What's the shape of it, and so on. What kind of services do you want on this posting, mailing that you want to do? All sorts of things control your prices. So you want to buy some electronic, and then they ask you, well, do you want this? Do you want that? Do you want that one? And so you have some options, especially when you want to go buy a car or something. Well, do you want floor mats? Do you want etching on your car? Do you want and so on and so forth. So they have all these choices, and the price keeps running up. 10%, 20%, the price goes up as you keep adding options to your car. So same way in mathematics, we play some kind of a scenario. We say if you have an input x, first decide which category x belongs to. So this is let's call this in category 1. Is your x less than -3 or at most equal to it? If so, use this formula, x plus 5. Then we have this category 2. So is x between -3 and 3? And then use this square root formula. If x is larger than 3, then use this other formula. So we have, in this case, 3 possibilities depending on what x happens to be. Let's go ahead and answer this thing. So part A, it says, what is f of -4? So first we have to decide, does -4 belong to category 1, 2, or 3? One easy way to tell that is to take the x-axis and say on that x-axis 3 regions. One of them comes all the way to -3, another one goes from -3 to 3, and then the other one. So let me color it. For example, we have maybe we have this region, inclusive of -3, we fall into the yellow region. And then if we are from -3 all the way to 3, inclusive of +3, we are in region 2. And in region 3 we have let's see what's left. Region 3 starts at a number larger than 3, and it goes all the way to infinity. So we have 3 regions here. So we have region 1, we have region 2, we have region 3. So if you choose from yellow or blue or red, we price it differently. If you choose from yellow region, like -4 falls here, is that right? -4. So I have to use the first formula, which is for that case, for region 1, f of x is just x plus 5. since minus 4 falls in region 1, I'll have minus 4 plus 5, and that is just 1. Well, B f of minus 3. Well, that is right on the border between the yellow and the blue. The problem tells you how to do kind of borderline cases. So the way we have defined it in region 1, minus 3 falls in region 1. So I'm still my input, which is minus 3 plus 5, and now I have to problem 3 is f of 3 itself. F of 3, well, where does 3 fall in? Is that blue or is that red? Well, since we have equal sign here for region blue region, 3 falls into this. So in this case, region 2, f of x is radical 9 minus x squared. This is for region 2. So f of 3 is going to be radical 9 minus 3 squared. And 9 minus 9 is 0, square root of 0 is 0, and that's it. Now if you move a smidgen, f of 3.001, where are we now? Well, this is 3.001, 3.001, we are in the red region. So in the red region, f of x is minus x plus 5. Is that right? In red region, for x is larger than 3, we have fallen in that, we crossed the red line. So it's minus x, so minus 3.001 plus 5. Well, what's that? 1.999. Notice that we moved a tiny bit from 3, and our answer is very different. Common situation in these piecewise defined function, that you move something a small amount and the answer changes quite a bit. And if you pattern your business like that, your customer will be unhappy because it looks like such a random thing. At any rate, so you want to be careful. So later on, if you study more mathematics, the functions that do this, they are called discontinuous. That is, you change the input a little bit, the output changes quite a bit. Those type of functions are a bit problematic and called discontinuous. At any rate, let's go to part E. It says, what is f of? It says we are doing f minus 3 point. Well, first question is, which region is minus 3.001? That is in the yellow region, minus 3.001. That's where we are. In the yellow region, we are using, let's write it here, this is, we are using x plus 5 here, we are using 9 minus x squared in the blue region, we are using minus x plus 5 in the red region. So there are 3 different formulas, and that's why I call piecewise defined. So once you decide that minus 3.001 is in the yellow region, all that you do, you have minus 3.001 let me see, I made a mistake here or no? No, that's the same. So plus, it's x plus 5. So x plus 5, I have now 1.999. Next, let's see what else we have. F of 2. What is f of 2? Well, where is 2? 2 is comfortably sitting here. It's not at the border. We're not going to make any mistake or anything. So what I have to use here is that radical formula, 9 minus 2 squared, and that is radical 9 minus 4 is 5. You can leave it like that. You can use your calculator, but better is just leave it that way because all the precision is there. Once you use a calculator, you lose some precision. Okay, so we learned one thing else, piecewise defined function. Again, these are very common in applications in business. As you make choices, change your mind about what business interaction you want to do, the prices could jump around based on your choices. And this is how we reflect it in mathematics. We write f of x is equal to, so the notation, and then we define as many regions that we might have, region 1, region 2, region 3. These are all choices you could have. The way we specify the choices is by inequalities. We say if x falls into this category, in this region, or this interval, so these are called intervals. When we specify a range of numbers from beginning to some end, we say we have an interval, and we have to be careful if the endpoints are included or not excluded, and so on. And we use a square bracket for inclusion, we use parentheses for exclusion, and so on. Okay, so we learned one more thing, piecewise defined function. Let's see what else is there. Okay, the next category, we have some simple word problems, again driving home the notion of a function. It says the area A enclosed by a circle in square meters is a function of its radius r when measured in meters. So what are we having here? We have a circle. The circle has a radius and has some area. We decide how to measure these things. So for example, we are measuring a radius in meters and then area in square meters. So this relation is expressed by the following formula. So A means area. A of R means area of a circle of radius r. So again, we emphasize we are not multiplying a by r. That wouldn't make any sense here at all. We are saying calculate the area of a circle of radius r. So this is a shorthand for that long expression there. A of r is area of a circle of radius r. We have a statement on r. We say r is a positive quantity. First it says what is a of 2. So let's write here a of r, famous formula from geometry from high school. Area of a circle is pi r squared, and pi is that famous number that has been there from the dawn of humanity, 3.1415. Okay, 3.14159265. So on. Over the ages, people have tried to find pi to more and more digits. A mysterious number there shows up also sort of places in mathematics, in particular in area of a circle. A couple of decimal places would typically suffice for most things that we want to do, but people have calculated it to billions of digits, and sometimes they use that to check new computers to make sure they do same thing. But at any rate, just writing pi would be good enough. You can always look it up What is a of 2? It's pi. So r is 2. We replace r by 2, 2 squared. So that's going to be 2 squared is 4 times pi. Now if you want to calculate it more approximately, you can multiply by any of this decimal representation. So this is going to be an approximation. Approximation uses a wiggly line. So that becomes 12.4 approximate value of this. It also says solve. So this is one part. Next part says if I have this equation, what does it mean and what's the solution of it? So that means your area of a circle was 16 pi. Solving it means find the r of the circle. That's the radius of a circle. Well, in any case, the area is pi r squared. And now this is 16 pi. Just divide two sides by pi, becomes r squared equal to 16. What numbers fit this equation? Well, we have two answers, plus or minus 4. But we remember we said r is positive, so we say r is 4. At the end, it asks, what do you mean that r is restricted to a positive number? Well, it's a matter of convention when you're talking about radius of a circle that the radius is a positive number. If you take radius to be 0, you're talking about the point, depending on your point of view, that might not be considered a circle. Again, that becomes a definition there. Most often they say a circle has a positive radius, so it has an interior to it. There is an interior of the circle. If you make it a point, well, there's no interior. Again, that is just a matter of convention and how you want to deal with it. But customarily, radius is taken to be a positive number until you go and take the next class, for example, trigonometry or pre-calculus, where they also try to make sense of r being negative. So there is a bit of a choice of convention here. For this book, r is positive until indicated otherwise. Okay, so that was another example. Let's see what else we have here. Okay, next question, a question from throwing balls up in the air or from top of a building and so on, and trying to figure out where the ball is going to be at any given moment. So if you're watching a football game, there's always this question in the background. When somebody's kicking the ball, how high is it going to go, how far is it going to go, after how many seconds is going to be back down there, and so on. So all of that is called an area named mechanics. So in mechanics, you always learn about this one. Here is a nice example of the problem. We have an object dropped from the roof of an 8-story building. So let's consider this building. That's a gray library, and say I am walking into the gray library, and you are up here, and you have a water balloon, and you're dropping it, and you want to be precise so that it will do what it's supposed to do. Well, either you have to figure it out experimentally, or take a course in mechanics, or just this course or something, and make sure you aim it right and drop it at the right time, etc. So this is one of the early examples of development of mathematics several centuries ago, when Galileo and others were studying how does something fall. So after many years, we have all these functions and everything that describe this thing to us. Here we have a height at time t. So h is the name of the function. T is time, so this means height. And this means time. So h is the height of the object off the ground in feet. So height is in feet. Time t in seconds. That's given by this particular formula, minus 16t squared plus 64. A friendly equation with friendly numbers, but it's kind of close to reality. So what is the setup? We have an axis, and this is our 0, and then we are going up. So this is the building, and this axis, if you wish, that's our axis h. Like when the water balloon is dropping, you at every second you record where it's gonna be at that moment. So for example, at time t equal to 0, well, that's probably the beginning of your experiment. That's when you're dropping the water balloon. Where is that? So h of 0, you say minus 16, 0 squared plus 64. Well, that's 64, and that means the 8-story building that you are on is 64 feet tall. That's how high you are above the ground. And then, so find it, it's asking us find h of 0. So this is h of 0. The unit of it is in feet. The meaning of it is that this is the height of the building. This is the height of the building. When we are solving, then next question asks, solve h of t equal to 0. h of t equal to 0. So h of t is minus 16t squared plus 64. Well, how do you solve this thing? Many ways. This being a simple equation, we can just use basic tools. I take my 64 to the other side, becomes minus 64, or I subtracted 64 from both sides. I divide. I get t squared is equal to 4. That tells me t is either plus or minus 2. And what's our unit? Our unit is measured in seconds. So we have two answers. Which one of them is applicable here? Well, again, it depends on your point of view. At time 0, you are holding this water balloon. You dropped it. At 2 seconds after that, your h becomes 0. So t equal to 2. The positive time, the time at which that you care about in this experiment, that becomes our answer here. So let's box everything. So h of 0 turned out to be 64 feet, and t equal to 2 seconds is when h is 0. Now the question is, what does this mean? Well, what do you mean that h of t is 0? Remember, h was the height. So when it is 0, it means you have impact. So h of 0 is what you are looking for, that water balloon that you dropped actually does hit me. So what's the moral lesson here is that you have to time it 2 seconds before I arrive at the door. You have to drop that ball. That's what it means. You have to see at what time am I be arriving at the door. 2 seconds before that, that's when you drop the ball. So what is the meaning of this? The meaning of this is h of 0. Interpret your answers. Well, we interpret it. why is time restricted between 0 and 2 seconds? Because that's the, if you let the t become larger than 2 seconds, it's as if you're saying your water balloon is going to go below the ground. Of course, you're not dropping some sort of bunker buster bomb or something. It's just a water balloon. It's going to splatter on the floor here. So this formula has a limitation on itself. The limitation is that as soon as the water balloon hits the ground, then that's the end of that formula. After that, something else is going to happen. So t equal to 2, it means a water balloon hits ground. Well, why is this? Well, this means we are releasing the water balloon at time 0. Perhaps before that you're just holding it in your hand. This formula is still, again, not applicable before you drop the balloon. So this is after the drop. So our formula, saying our formula is good from the moment that you drop the ball until it hits the ground. What was it doing before? Well, I don't know where the water balloon was before, and I don't know what happens to it after it hits the ground. But between these two moments, I have this formula for you. That's what we are interpreting. Okay, so that was an example of a problem. This thing, something like this, the short word for this thing is domain. Domain means a set of values of the input variable that we are focusing on. Now, our focus could be because of a business application or some sort of moving application or something like this problem, or it could be mathematical application that we just limit ourselves in a certain way, because the formula itself, regardless of what you wanted to mean by it, cannot go that distance. So if I had a formula like, let me write in white. So if I had h of x, or let me change this thing perhaps to some, say g of x. Say I have 2 over x minus 3. That's a formula, as good as any other formula we have. Now, aside from any application that you might have in mind, the formula has its own restriction. Division by 0 is not allowed, so x cannot be 3, so you are limited to one of two domains. Either x is less than 3 or x is larger than 3. But definitely x is not 3, because we don't know how to handle the resulting infinity. So these two together can be expressed like that, and then that's going to be called the domain. If you want to interpret the domain in a picture, you can say on the x-axis go to 1, 2, 3, take that point and clip it off. So clipping it off, sometimes they show it by a little circle, and then you're allowed to be on the left or on the right, but not on the red area. And then they say, okay, in interval notation, the left from minus infinity to 3, you can be there, or from 3 to infinity you can be there too. That's called interval notation. So sometimes you see that interval notation. But in a shorter way of describing the same thing, say, well, keep x different from 3. So again, this wasn't an issue of anybody falling or any business application or something. The formula by itself has a limitation, and that is typically what we refer to when we talk about the domain of a function. Okay, So these were some ideas about the domain. Let me just mention a few other items. We have an easy way of describing how a domain of a function looks like if you have a picture of the function. If you have a graph of a function, suppose we have a function whose graph starts from here and goes here, whatever these points are. So we have a picture of a function and it has this funny looking curve to it and so on. What is meant by the domain? The domain is a set of x's for which you have the function above it. So this is the domain. These are x's that at which point if you go vertically up, you are going to hit the graph of the function. Now how about the range? The range is sometimes called codomain, set of values on the y-axis that you can arrive at so here if I start with this x, I'll arrive at this y, or if I start at this y, I can trace my way back to a particular x. So sometimes for simplicity we call this one the range. Sometimes other words are used. So the idea of a domain and range are ideas that we might come across later on. Okay, so what did we do today? We went through function notation. We expressed how do functions come about. We said f is the name of a process. F of x means what you're going to do to value x. It does not mean f times x. And then we solved several examples to drive that issue home. Okay. Until next time, good luck and God bless.